Okay, this is section 5.7. We're going to be talking about arithmetic and geometric sequences. You would have talked about this in Algebra 2, late um, chapter, I don't know, 11 or 12. It would have been late in the school year. But anyway, this should be review for you, arithmetic and geometric sequences. A sequence is a list of numbers that are related to each other. The numbers in the sequence are called terms. A famous example is the Fibonacci sequence. And the first term is 1, the second term is also 1, but to get the third term, I add these two together. 1 plus 1 gives you 2. To find this term, I add the two previous. 1 plus 2 gives me 3. 2 plus 3 gives you 5. 3 plus 5, 8, etc. Notice the notation here. This is subscript. This is the, we always use A for a sequence, and this subscript 1 means it's the first term in the sequence. This subscript 2 means it's the second term in the sequence. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. In other words, what you're doing is adding the same number each time. So for example, if I start with, I don't know, 7, and I add 4, and I add 4, and I add, oops, hold on, and I add 4, and I add 4, this would be an example of an arithmetic sequence. And notice how I pronounce that. This is spelled arithmetic, but since it is an adjective, it's describing the type of sequence, it's pronounced arithmetic. So you pronounce it differently since it's an adjective, not a noun. The difference between two consecutive terms is called the common difference. In that example that I just, erased, the number that I was adding each time, that would be called the common difference. So in this case, D would be equal to 4. So here we have a few sequences. We need to find the common difference. So I have 142 to 146 to 150 to 154. What number are we adding each time? 4. How about this one? Negative 5 to negative 2 to 1 to 4 to 7. What are we adding each time? Now, you don't have to just add a positive number. In other words, you can add a negative number or subtract. If I go from 5 to 3, or sorry, if I'm going from 8 to 3, I'm not adding 5, I'm actually subtracting 5. The common difference would be negative 5. So it's allowed to have a negative difference. Oh, here we go. Write the first 6 terms, so a sub 1, a sub 2, all the way up to a sub 6 of the arithmetic sequence. We're adding the same thing each time. The first term is 6, and the common difference is 4. So we start with 6, and for the first time, to go to the second term, I'm going to add 4, so then I'm going to get 10. I'm going to add 4, I'm going to add 4, add 4, and add 4. So the first 6 terms are 6, 10, 14, 18, 22, and 26. Now, what we're going to want to do actually is come up with a general formula, so I want you to see the pattern here. So for the first term, I have 6, and I added 0 common differences. I didn't add any at all. To get to the second term, to go from 6 to 10, I added 4, which is one of the common differences. Now be careful here. I am going to erase some of this so we can see what's going on. 6, there we go. 6 and 10. All right. Now, to get to the third term, I add 4 to the previous term, but that's not the question. The question is, what did I have to add to the first term to get to 14? Well, I added 4 this time, and I added another 4, so I actually added 2 common differences. So now let's take a look at the fourth term and figure out how many common differences I added. Here we go. So here I am at the fourth term. I added one common difference, two common differences, three common differences. So I added three common differences to get to this term, four and five common differences to get to the sixth term. I want you to notice right here the subscript. The sixth term I added five common differences. The fifth term I added four. Fourth term I added three. Do you see the pattern here? If I want the 70th term, a sub 70, how many common differences do I have to add? I have to add one less. I have to add 69 common differences. All right, you see where I'm going with this here? So our goal actually is to end up with a formula. So the first term, second term add one common difference, third term add two, fourth term add three, etc. So to find the formula, what we're going to do, and by the way, a sub 1 always refers to the first term. The formula says we take the first term and we add a certain number of common differences. Well, when we're doing this, we call D the common difference. This, in parentheses, tells us how many common differences we want. So we're on the nth term. It would be like saying the xth term. Well, that sounds kind of weird. So we say the nth term. Well, if I need one less than n, I subtract one. The formula is, and you're going to need to know this, this is important, the first term plus one less common differences. Now, find the eighth term of the arithmetic sequence. First term is 4, common difference is -7. Now, can you take the first term and find the second term and find the third term? Yes, you can, but that's a whole lot of extra work. We are just interested in the eighth term, and that's it, done, the end. So just to find the eighth term, I don't want to find the seventh term. I don't want to find the sixth term. I just want the eighth term. So what I'm going to do is I'm going to use that formula from the prior page. The first term is 4, so a sub 1 is 4. Since I want to find the eighth term, I have to take 1 away from that to figure out the number of common differences, which the common difference is -7. So a sub 1, n minus 1, d. And I calculate what that is. Remember, with order of operations, you do what's inside the parentheses first. You multiply before you add. And the eighth term is going to be a -45. Could you find it the other way by going through all the terms? Sure. But this is better not necessarily when you're trying to find the eighth term. Finding 7 terms is not that bad. But when you're trying to find the 200th term, would you want to find all 199 before it? Probably not. Geometric sequence, on the other hand, is when we multiply by the same thing each time, called the common ratio. Multiplying the same thing each time, we call that the common ratio. So, figure out the common ratio. What are we multiplying by? Sometimes it's pretty obvious. I go from 1 to 5, 5 to 25. You can see clearly that I'm multiplying by 5 each time. 4 to 8, 8 to 16, I'm multiplying by 2. But let's take a look here. Sometimes it's not, well, it's still. There we go. notice you have a positive number, then you have a negative number, then you have a positive number, then you have a negative number. What that says is that your common ratio has to be negative. Okay? So to go from 6 to negative 12, you multiply by negative 2. From negative 12 to positive 24, you multiply by negative 2. And as I was starting to say, but didn't get there, is sometimes it's a bit trickier to figure out what the common ratio is. So the easiest way to figure out the common ratio, if you can't just see what it is to take the second term and divide it by the first term. So take the second term divided by the first term. The common ratio is negative 2. And it doesn't actually have to be the first and second term. What you can do is take any pair at all, doesn't matter, take the second one divided by the one that's prior. So if you take 625 divided by 125, you'll get a common ratio of 5. Write the first 6 terms. So a sub 1, the first term is 6. The second term, I don't know if you can hear that drilling, I apologize. Not much I can do about it. Common ratio is 1/3, so I'm going to multiply that by 1/3. And if you don't know fractions by now, I'm thinking it's pretty much too late. Buy a scientific calculator, it will do fractions for you. 6 over 3 is equal to 2. The third term, I'm going to take 2 and multiply by 1/3. I get 2 over 3. The fourth term, 2/3 times 1/3, 2 over 9. I'm running out of room. Let's see if I can go over here. A sub 5. I take my last term and multiply by my common ratio, and I get 2 over 27. And finally, the sixth term, multiply by 1/3, and I get 2 over 81. For the general formula for this one, I'm not going to, walk you through it. This is the formula. You will need to know it. Make sure you memorize it. This is important. One thing that is kind of got left out, that actually should be in parentheses. So make sure you put that n-1 in parentheses. Okay, sorry about that. I had to take a little, got interrupted. So here we are back. We have the general formula for common ratio, or the geometric sequence. And like I said, you do have to memorize this. So let's use that general formula. I'm looking for the 8th term in a geometric sequence, so I have to use the geometric sequence formula, not the arithmetic sequence. So geometric says take the first term, which is -4, multiply, the common ratio is -2. I'm going to raise it to n-1. Since this is the 8th term, I want 8 minus 1 as an exponent. Be very careful when doing this, because you do not multiply the -4 times the -2 and get 8 to the 7th power. This is not 8 to the 7th power. You have to do parentheses first, grouping parentheses first, which is 8 minus 1. Then you do exponents. You take -2 to the 7th power. And offhand, I have no idea what that is, so 128 it looks like. And since it's negative, remember that's, so start out with negative 2 to the first, positive 4 squared, negative 8 to the third power, positive 16. So notice the sign alternates as well, so be careful with the sign. So negative 32, positive 64, negative 128. So first power, second, third, fourth, fifth, sixth, seventh power. So here we go. Now multiply negative 4 times negative 128. And I'm going to cheat, use a calculator, times, I get, negative times negative is positive 512. Positive 512. And your homework, 8 through 112, every 8. What that means is start with number 8, then do number 16, add another 8, do number 24, add another 8, do number 32, etc.